A warp bubble, also known as an Alcubierre drive, is a theoretical propulsion system that could potentially allow faster than light travel. The design is based on the concept of creating a bubble of space-time around a spacecraft, which would contract the space in front of it and expand the space behind it. This contraction and expansion of space would allow the spacecraft to move faster than the speed of light without violating the laws of physics that prohibit objects from exceeding the speed of light within spacetime. The design of a warp bubble involves manipulating the fabric of spacetime using a hypothetical form of matter called exotic matter, which has negative energy density. The exotic matter would be used to create the bubble around the spacecraft, which would then move within the bubble. The spacecraft itself would not move faster than the speed of light, but would be carried along by the bubble as it travels through spacetime. The concept of a warp bubble has been explored in theoretical physics, but it is still purely theoretical and has not yet been demonstrated experimentally. There are also significant technical and scientific challenges associated with the design and construction of a working warp bubble. Nonetheless, the concept of a warp bubble continues to be studied as a potential solution to the challenges of interstellar travel. To explain the concept of a warp bubble in more detail, it's important to understand the basics of how space and time are intertwined in the theory of relativity. According to Einstein's theory of relativity, space and time are two aspects of the same fundamental entity called space-time. Objects in space-time move along a trajectory through both space and time, which can be thought of as a path through space-time. The speed of light is the maximum speed at which an object can move through space-time. This limit arises from the fact that the geometry of space-time is such that as an object moves faster, the amount of time it experiences becomes less, and the distance it travels through space becomes longer, so that the overall speed is still limited to the speed of light. However, the concept of a warp bubble involves the manipulation of the geometry of spacetime itself, rather than the movement of an object within it. The idea is to create a bubble of spacetime around a spacecraft, which would contract the space in front of it and expand the space behind it. This contraction and expansion of space would effectively stretch the space-time fabric between the spacecraft and its destination, allowing the spacecraft to travel faster than the speed of light as measured within the bubble. The design of a warp bubble requires a form of matter with negative energy density, called exotic matter. Exotic matter has not been observed in nature, but is a theoretical concept that arises from the mathematics of quantum field theory. The exotic matter would be used to create the warp bubble by bending the spacetime fabric around a spacecraft in a way that would contract spacetime in front of it and expand it behind it. One of the challenges with the concept of a warp bubble is that it requires an enormous amount of exotic matter to create a bubble large enough to accommodate a spacecraft. Additionally, there are still many scientific and technical challenges to be addressed in order to create and control a warp bubble, and it is unclear whether such a technology will ever be possible to build. Nonetheless, the concept of a warp bubble remains an active area of research and speculation in the field of theoretical physics, as it has the potential to revolutionize our understanding of spacetime and the possibilities for interstellar travel.